Hello all and welcome back. So in this video, let us continue our discussion on stacks. And now let's see what are the different operations which we can perform on a stack. So let's get started. Now to understand the operations which we can perform, let us just think and write them one by one. We are going to take an example and understand and rather derive each and every operation from this Pringle can only. I think it is a lot uh, relatable example, right? So the very first thing which all of us do, which we can do as well is eating, or I would say rather pop a chip. Okay, so that is known as pop, which is, or rather the very first one which we can right now even do is we can see the first chip, right? So we can see how the first chip is. So for that we say that operation as top or peak. So you are able to see the top element, right? Let me write the definition. See the top element, right? That's the very first operation which we can do. Now let's talk about the second operation, everyone. The second operation is we can pop a chip out of it. So pop is, if I write down, it's removing the top element. Removing the top element. Of course, the very first chips or chip which you can remove is going to be this first one, right? So I'm of course thinking that it's one by one. Like don't take so many chips altogether. Great. The next one is which we can think is, if let's say you have a chips in your hand and you want to put it back into your packet, into your this box, so that is known as push. So push is basically when we insert an element on top, right? So insert an element on top. I think that all of these are a lot intuitive to understand. We can see the top chip, we can get and eat it, and we can push a chip back into that as well, right? Let's say we have two half boxes, then from one to other, we can just keep on putting in chips into the into one of those. So that is what is known as push. Push an element into the stack. Okay. Of course, that is going to come on top always. Let's say you pick out this chips, you don't want to eat it, you will be putting it back. Great. So the next one is to see how many we have. That is known as size. So that returns number of element, number of elements in our stack, right? So this is just helping me to understand how many chips, how many elements do I have left. It will give that number. Okay. And the last one can be empty or is empty basically. I think it's a lot explanatory, which tells you if our stack is empty or not. So these are the 5 operations which we can do on this particular stack data structure. All of them I have make sure that it is intuitive to understand, not just writing that down. Because I feel that if you think about each and every operation, that becomes a lot more clear, right? So all of them we have seen that how that can be done from this bag of Pringle. Now, as I said in the last class, we are going to make sure that we are implementing our stack from scratch. Okay. So the same can be done using a linked list, an array, or even a list. But we have to somehow make sure that we can restrict the operation. So for that, we have already seen and we know about the concept of OOPS, right? Where we can restrict the overall operations. So what will happen is that, let's say this container is your linked list, array, or even a list. We will make sure that we are implementing our stack using any of these. And although it has so many operations, we will just make sure that for me, 5 operations are present. So I don't need to worry how they are implemented as an end user. Okay, let me write it a little clearly. So for me, just these 5 operations are present. Okay. So we will hide all the other operation. Yes, I know that in an array, in a list, in a linked list rather, we have done all these things where we can insert in middle, we can delete from any position and all these stuff. But for our use case, we will not be having any of those operations. We will just have these 5 operations, because in that way, I am making sure that it is behaving like my stack, right? So in the backend, we will be using an array or a list only. But the understanding is that I will restrict the operation to make it behave like a stack. One thing more here, everyone. If there is some function which you want extra, okay, then that is not your stack. Okay, so don't say that tomorrow you want a stack where you can access anything from middle. That's a wrong terminology. Okay, that is not a stack. Okay, and if you want to use, or if you have want to have some other operation added to this particular thing, then too this will not be a stack which we have discussed. So tomorrow, if you want, then you can insert or delete from both the sides. That is not a plain stack. Okay, that is not a single sided stack. Maybe that we can talk as double side, but make sure that you have an idea that when we talk about stack, these are the things which we can just do from it. Along with that, because we are now just dealing with 5 operations, we have to make sure we will make sure that these 5 operations are optimized. Okay, so again, we have been learning about the optimization a lot. So the major idea behind using stack will be some optimization only, right? So in any use case, when I feel that okay, these are the operations which I have to do, but if I'm not being able to do them optimizingly, using like with good optimization, then it's going to be a problem, right? So we have to make sure that these operations are optimized, something which we are going to see once we go on implementing them. So in the next few videos, we will implement our stack from scratch to see that okay, how it can be done, and then using the same after that to solve some problems. Okay, great everyone. So I hope the overall operations of stacks are now clear. So let's now meet and try to implement our own stack. Thank you.